Introduction to Linear Programming. A linear program is an optimization. We want to find the best value we can get under certain conditions. Problem in which all involved functions are linear in X. In particular, all the constraints are linear inequalities and equalities. Linear programming is the subject of studying and solving linear programs. Let's see how it works. Consider a candy manufacturing company which produces only two types of candies, A and B. Both the candies require milk and chocolate only. To manufacture each unit of A and B, following quantities are required. Each unit of A requires 1 unit of milk and 3 units of chocolate. Each unit of B requires 1 unit of milk and 2 units of chocolate. The company kitchen has a total of 5 units of milk and 12 units of chocolate. Let the total number of units produced of A be X. Let the total number of units produced of B be Y. As we see above, each unit of A and B requires 1 unit of milk. The total amount of milk available is 5 units. We can represent this mathematically as X plus Y is less than or equal to 5. Also, each unit of A and B requires 3 units and 2 units of chocolate respectively. The amount of chocolate available is 12 units. We can represent this mathematically as equation B. Since the values of A and B can only be integers, we have 2 more inequalities. The inequalities A, B, C, and D are called the constraints. Now let's solve the simultaneous linear inequalities. On each sale, the company makes a profit of $6 per unit A sold, $5 per unit B sold. The total profit Z the company makes is given by Z is 6 times X plus 5 times Y. The last equation is called the optimization equation or objective function. The company will try to produce as many units of A and B to maximize the profit. Find the maximal profit. Now we have to graph the constraints as we did in the previous session on simultaneous linear inequalities. Let's solve the inequality A for Y. Draw the line. Let's solve this inequality for Y. Let's draw the line. Draw the line. Draw the line. Now we shade the regions. This shape on the XY plane is called the feasibility region. The maximal or minimum of the objective function occurs at one of the vertices, corner points, of the solution region polygon. So we need to find the corner points. These are the points, the corner points. Now, to find the solution to this exercise, we only need to plug these 4 points into objective function. X is 0, y is 5. X is 2, y is 3. X is 4, y is 0. X is 0, y is 0. Then the maximum of z is 27, occurs at this point. Graph the constraints and find the maximum of the objective function. Constraints. Let's solve for y. Draw the line. Solve for y. Draw the line. Solve for y. Draw the line. Draw the line. In this example, once we have drawn the graphs, you should realize where the feasibility region is. I think it's clear where the feasibility region is. We don't need shade. Let's find the corner points. Substituting these 4 points into objective function, we get then the maximum of z is 27, occurs at x value 4, y value 3. Linear programming exercises are pretty straightforward. The hard part is usually the word problems, in which you have to figure out what the inequalities are. So pay attention in the next typical linear programming exercise.